Somewhere.
Somewhere past the edge of convention.
Beyond the boundaries of tomorrow
lies a special kind of impossible.
A kind of impossible.
Where pioneers forge ahead.
Where no idea is too bold.
And no challenge too great.
Because making a 200-ton airplane disappear is impossible.
Until it's not. Predicting cyber attacks before they happen is impossible.
Until it's not.
And solving the mysteries of the universe is impossible.
Until it's not. It's our job to break free from what is to what could be. Ready?
To leave the boundaries of what's known.
To define possible.
To define possible.
define possible.
To define possible.
To define possible.
To define possible.
I'm Captain Randessa Hankins from the 86th Logistics Readiness Squadron, Ramstein, Germany. Our next speaker is a partner from industry, Justin Mcmurray, from Northrop Grumman. Justin Mcmurray is the Vice President of the Autonomous and Tactical Air Systems Operating Unit in the Global Sustainment and Modernization Division of Northrop Grumman's Defense Systems Sector. His division provides broad-spectrum technology services, sustainment and modernization solutions, integrated battle command systems and tactical weapons and information systems, focused on evolving threats and quick-turn requirements for a wide variety of national security, military, and civilian customers. Ladies and gentlemen, Mr. Mcmurray.
Good afternoon, Loa. I hope everybody's doing well. It's been a great conference so far, and it's an honor to spend a few minutes today to share a topic I'm passionate about: how to improve logistics in design, manufacture, and sustainment of our systems. As Loa is a learning forum, I'll also share some thoughts on leadership. And at the end of my presentation, I'll open it up to Q&A. So first, I wanted to set the context for my presentation. I work for a great company. Northrop Grumman. This slide shows examples of some of the things that we do. We have 97,000 employees that work to solve the toughest problems in space, aeronautics, defense, and cyberspace. And to begin, I'd like to take you back to when I first joined Northrop Grumman. 18 years ago, I started as a software. And okay, maybe this picture is a little bit more than 18 years ago. But I do like how excited and curious I look in this picture. Much like how almost all of our new employees look on their very first day at work. My education up to that point had focused on designing new things, and my first job was sustaining a system that was deployed before I was born. That system is Minuteman III, our land-based portion of the nuclear deterrent. I was amazed to learn that we provide the nuclear umbrella for the entire free world. We've told all the other free world countries, you don't need nuclear weapons because we've got you covered. And as I learned more about that and began digging in at work, I was equally impressed with the mission commitment that the Air Force and industry partners brought together to show that commitment to keep our nation and our allies safe. As we did that, I learned the breadth of logistics, configuration management, integration, predictive planning, maintenance activities, all the complexities of the nuclear world coming together, sharing broad skills that are required to keep our missiles on alert long after their original design life. I also learned that logistics tools continue to evolve long after a system is deployed. So let's fast forward to today. And DoD has a huge emphasis on digital engineering and modernization, a focus for us to move faster and be more cost effective. As General Brown said, we need to accelerate change or lose. And we don't want to lose. So the digital transformation is a key aspect of moving faster and being able to react quickly. Within Northrop Grumman, we're aligning to that strategy and transforming our business. And I'll go into details on the upcoming slides on how we're pioneering digital innovation. This slide shows a great new development program, GBSD, or Ground-Based Strategic Deterrence. We're executing on that today, and we're leveraging open systems to allow for rapid and affordable tech insertion, which is really important for a system that is going to have a 50+ year service life. When you think about it, some of the people that are going to operate this system aren't even born yet. In fact, the parents of some of the people that are going to operate this system haven't even been born yet. And so when we think about how to design a system for things that are going to be many generations in the future, we need to design it in a way that it can be changed and modified and maintained as the future matures. Think back 50 years and how different the world was. We don't even know for sure what the world will be like in 50 years. But in partnership with the Air Force, we're creating the new system with an open system architecture that allows us to make changes and affordably maintain it far into the future. We're also using modern digital design tools. We're accelerating agile software development cycles, which allows us to have more mature and lower risk solutions early on in the program. This helps us create a new deterrent system that's safe, secure, effective, and affordable. Next, I'd like to talk a little bit about how digital design ties into manufacturing. We're focused on creating factories of the future. And the photo that I'm showing here is of our production facility in Palmdale, California. This is the facility where we build F-35 center fuselages prior to delivery to Lockheed Martin. And this facility was honored by Aviation Week in November 2020 with the Laureate Award in Defense Manufacturing. Our team has made huge investments in digital tools, such as automated drilling and self-inspection probes that are powered by data analytics and sensors, so that we could drill more than 5,000 holes, countersink them with precision accuracy, and have them do self-inspection. These investments have enabled us to have the factory increase production capacity from 6 units per month to 15 units per month. And so what does all of this production have to do with agile logistics? If you can have precision design, you can have predictable sustainment, and copies of the things that you're sustaining that are the same of each of the units that you're producing makes it a whole lot easier to sustain. And also the digital tools that we're using will support throughout the product lifecycle and also make it quicker to inject changes when needed. Another production automation example is in our electronic components areas. We're automating the dull, dirty, and dangerous tasks that operators have been doing manually. What we do is we create a digital twin of the actual workstation. We put it in a virtual environment and we run 3D simulations prior to actually receiving any product or hardware. We then translate that to the real world, where the 6-axis robots coupled with machine vision give the ability to see and decide what's good and what's bad. And we're taking technologies such as deep learning, so we ingest more and more data. The better the data set comes in, the smarter the robots get, the better the inspection and classification becomes, and generations continue to build and build upon what's being done there, creating factories of the future. Another digital focus area is software development and sustainment. Many of you have heard in earlier sessions about DevStar Ops, which is linking development, security, and operations together, allowing us to have rapid software development cycles, including continuous integration, continuous testing, continuous security, and continuous delivery and deployment. We've been implementing DevStar Ops for some time now, and our mission critical systems are demanding even more than what DevStar Ops brings. So in partnership with the Air Force, we're creating an all-encompassing strategy called DevStar Ops. For the coders in the audience, I know the star or the asterisk symbol is a symbol that's familiar to all of you, a wildcard character that encompasses many different things. So rather than just that security as the middle part in the DevStar Ops, there's other features that embedded systems demand, such as safety or airworthiness. And so the star is representative of what other things can we automate? What other things can we model? What other things can we combine together so that we can get speed, quality, focus, all integrated together, and much earlier in the design cycle, get inputs from those key logistics and sustainment elements so that we can deploy quickly and stay ahead of our adversaries. I'd also like to talk about virtual system integration labs. We all know that we have operational systems today, and if you need to modify something directly on the system and you need to test directly on the system, it's time consuming, it's expensive, it makes it so that we can't use those systems operationally. So when we're all done with development, we need to go put it on, test that it works really well, and use that full asset for that integration. To move quicker and at a lower cost, we've developed system integration labs and weapon system trainers where we have the real mission operational flight programs that are, and the high fidelity simulations that allow us to show what's going on with the operational systems. And then at the very bottom of this slide, we've even taken that a step further and said, how can we make this so an individual or a small team can innovate rapidly and can develop with modern software tools? So we've taken many of the hardware components and we've virtualized them. So we've taken, the system integration lab functions, the trainer functions, the high fidelity simulations, and we've put them on COTS hardware, and we're able to emulate the actual mission displays. And we've got automated scripting, modern software tools. We can emulate the interfaces such as MIL standard 1553, et cetera. And then each individual or small team very rapidly using modern software development tools can take these current platforms that are out there and test new capabilities, integrate them in, and make it so that they get deployed to our warfighters a whole lot quicker and at a much, much, much lower cost. So I'm really excited about the capability that these virtual system integration labs are providing us today. The next area I'd like to talk about is using virtual and augmented reality. Its use is exploding. When we can bring our physical world together with digital technology, combine model-based systems engineering and digital design, we can rapidly research, come up with ideas, prototype, and test. And this makes it so that we can go through design iteration cycles so much more quickly. When we're doing that, we can bring in the maintainers, the operators, and be able to show real relevant information, such as physical features that you'll see when the system is done. And a lot sooner than when we've bent metal, we can get that feedback to make sure we're designing systems that are highly maintainable. The next slide will show some specific examples of how we're using virtual reality today. In the top left here, you see a person reaching. This is a person that has some special stickies on them. They are digital sensors that have been put on that individual, and we've got a highly immersive virtual environment. So a computer system can very accurately track the movements that that individual is making. And on the back screen, you can see that movement replicated in the digital environment. So early on in the design, we can do reach studies, we can look at human factors designs, we can look at what shop aids we may need to have to be able to perform, and make sure we're thinking about the holistic system up front with this kind of technology. On the top right is another example. This one is augmented reality. So this allows us to bring people together and be able to see technical documentation overlaid as you're doing your work instructions. And instead of the old black and white instructions that we sometimes have, you can embed images, you can embed videos, and you can see real time the work you're trying to accomplish. And then when you need to log the work that you've done or look up information, we also have a virtual holographic keyboard. So you don't have to return back to a workstation if you need to go look something up. Just right in front of you, you can continue to execute with this augmented reality technology. The bottom left picture here illustrates immersive virtual reality. So put on a headset and transform so that you can train on critical functions and gain proficiency on important aspects of a system without having to tie up operational assets. Also an opportunity to simulate emergency situations. Obviously, really hard to simulate fires with operational systems without destroying them. And so being able to simulate and replicate those kind of off-nominal situations so we can train and be prepared for things in the real world is extremely helpful and allows us to get maintainers that are able to operate much more quickly in the environments they're operating in. The bottom right picture has someone that has a small augmented reality lens on their eye, and they also have a camera on that. So with that small eyepiece, they can look up technical information, mark tasks as complete. They can also push a button to say, give me some reach back support to engineering. Something's not going right. How can I solve this challenge I'm seeing in front of me right now and not have to take some pictures and wait days for a response, but real time, get that connection and get that answer that you're looking for. Operationally, these are things that take some cybersecurity in order to make sure that they'll be able to be used. And it's been a huge focus for us this past year of making sure the right cybersecurity is embedded so that these can be used on the operational networks where we need to use these going forward. Another neat technology is the ability to do 3D scanning and then use that to solve the legacy platform issues that we have, the current system issues, where we have a nick, dent, scratch, other issue that comes up. In this example, we have an engineer has his 3D scanner, can quickly walk the length of the aircraft wing here. And as he's going, there's a computer on the right-hand side that shows a digital model being created as the employee is scanning the picture here. This allows us to have exact defect characterization, so we don't have to, go figure out, was that an inch, was that 2 inches, exactly how deep it was. Allows us to quickly address things like aircraft battle damage repair. If we don't have tech data, we can regenerate the tech data quickly with some of the back-end databases that we've linked up with this. And for new systems that we're just fielding, if you 3D scan the part and you compare it to the tech data that it was, as built compared to as designed, you can accelerate first article validation. And on this next slide, we're going to go into leadership and shift gears here a little bit and talk about some leadership aspects in SLO as a leadership forum. I'm very grateful for many leaders who took a chance on me. And like this example shows, sometimes you got to let people try new things. And I've had many examples throughout my career where people have said, Justin, we're willing to let you try something new. And I'd like to share more about that on the next slide here. When I started my career at Northrop Grumman, I was an intern. And sometimes you think intern, okay, going to be making copies or helping get coffee for people or tasks that aren't too strenuous, too mentally challenging. And when I started, I was given real work to do, which was critical to my decision to stay with Northrop Grumman long term. I was invited to write real code, and people listened to the ideas that I was bringing forward. I had a project manager and a mentor, Ed McCann, who introduced me to systems engineering and helped me understand the complexities of building and sustaining complex systems. I continued to study and learn more about that and was fortunate to be selected for a rotational program we have at Northrop Grumman where I was able to do rotations around the company. I moved to Florida where we were connecting flight simulators together that weren't designed to talk together. I went down to Louisiana where we were designing new ships for the Coast Guard. I took a stint in missile defense applications in Virginia. And at the end of my rotations, my wife and I had just had our first baby. And we decided we wanted to be with family for a while. And we wanted to move back to Utah. And so I knocked on the door of my friends in the ICBM world and asked if they would find a position for me. And they said, yep, we'll take you as somebody that we used to know as a software guy and put you as a propulsion sustainment engineer. And that was something that was very different from me. As I look at taking on that role, what did I know about propulsion and sustaining ICBM systems from a propulsive aspect? I learned a little bit on some of my rotations, but I certainly didn't have that in-depth knowledge that many senior folks had in propulsion. And some of the things that were critical for me being successful in that were networking with other individuals, finding ways to quickly add value, bringing in things from past experience, and making sure that I had good mentors that I could reach out to. From there, the things that I had learned had snowballed into other opportunities within the company, grabbing a bit from each experience that I had, connecting with people that I had met along my journey, continuous education and continuous learning as I achieved systems engineering certificates and program management certificates, continued my education and got an MBA. So continuous learning has been critical to my role. And 6 years ago, I was extremely surprised and honored and humbled when Northrop Grumman selected me to lead a large business unit. I'm so grateful for the many people who have taken a chance on me. And as leaders, one of the things we need to do is take a chance on others and continue to focus on how we can develop everyone around us. As part of that, another leadership key is don't believe everything you think. For those that read this quickly, you may not have caught that the slide says you twice. And the light bulb that shows up inside the light bulb, there's a tree. And so I'm going to elaborate on this don't believe everything you think phrase on the next slide. Back in 2015, psychologists from around the world tried to recreate 100 important psychological studies that had been released in prominent journals. And when they did that, they found that just 39% of the claims made that had been published in those journals could be reproduced unambiguously. And even then, the results they found were less significant statistically than the original findings. There were areas that weren't able to be reproduced about men and women and their choice of romantic partners. They were areas where people looked at labeling objects and, if you slow down how it would go, racial bias, many other things that seemed key the first time somebody studied something, they found different results when they went back and re-looked at it. So why do I bring this up? We've all heard of unconscious bias. So how do we push back against it? We need to seek diverse opinions. We need to examine conditions that led to an outcome in the past. We need to look for conditions that may be different now. We've heard sometimes that something didn't work in the past. We need to question that. We need to encourage innovation. When people come to us with great ideas, we need to say, great, that's an awesome idea. Let's explore that some more. Let's not say, we've tried that before, it doesn't work. Let's share why it didn't work in the past and talk through things that may enable it to work in the future here. Now, finally, before I go to questions, I'd like to share a different perspective. About every 45 minutes, astronauts on the ISS see a sunrise or a sunset. And this is indicative of how the world around us is changing. It's speeding up. And we need to keep finding ways to move faster and think differently to support our warfighters and protect our way of life. Dr. Roper has said, let's e-create before we aviate. Let's get those digital models. Let's move forward with new innovation that'll allow us to go faster and farther together. In summary, you are the future of aircraft logistics and sustainment activities. Your ability to continue to innovate and break down barriers is critical to agile logistics and maintaining our warfighting advantage. Thank you for all that you do for your service to this great country. And now I'd like to hear from all of you. What questions do you have that I can answer? And I'll go to the chat window now. See what's coming in here on chat. Okay. All right. So question came in on headway on 3D printing and printing parts for the nuclear enterprise. I can't get into a lot of details on this call, but I'm happy to say that we are doing a lot with 3D printing across Northrop Grumman. We have a relationship. I just showed this picture. One of the first 3D printed wrenches in space, and 3D printer that went up in space. We partnered together to make that happen. So we are making headway in 3D printing. I'm happy to talk offline if there are some specific questions that people would like to ask me in a smaller audience. I can get into some more details there on specifics. Next question here from Major Ryan. Working in the ALCs, I realized it was difficult to recruit and retain engineers. Do you have any programs or advice on how we recruit and retain talented engineers? That's a really good question and an important question for all of us, right? If we can't get the right people in, we can't get the job done. And there's a lot that can be done to recruit people and help them see the value for the work that we do here. Sometimes the mission is something that draws people in. That's what's kept me with Northrop Grumman for the long haul here, and helping people understand that they'll make a difference. Sometimes when people say, I got an opportunity to go work with Google, you can say, great, do you want to put ads on people's computers, or do you want to make a difference in the world? And there's things that we are doing that every day protect our way of life. I talked about how when I first joined Northrop Grumman, I had the opportunity to do real work and to innovate and to do creative things. And the more we can create processes that allow us to move quickly and allow us to work together versus, serial, have to wait for one group to complete before you move to another thing, then we can help people come in. Having a great quality of life and a work-life balance is something that sometimes we can offer in this industry that is not always available to others. So there's a few ideas from me on things we can do to recruit and retain engineers. Related to that is outreach to schools and continue to engage on an educational basis and talking to the high schools and the universities about the opportunities that we have from the real work that we do. And that's one of the primary reasons that I ended up in this industry. I had a college calculus teacher that reached out to me, and he made calculus come to life by sharing real world examples. And when there was an internship opportunity at Northrop Grumman, I reached out to him and said, hey, can you help me get a job? And he brought me on board. So that connection with the educational institutions is really an important one. Okay, next question here is in regards to public-private partnerships. How are Northrop Grumman's contributions helping to sustain aircraft? So our partnerships are incredibly important for sustaining aircraft and working together with the government. On just about every system that's out there, there's a mix of what industry does and what the government does, and working together in those partnerships and figuring out where the best athlete is for all of the work that needs to be done and how we work together to sustain aircraft is critically important. There's pieces of work where we have public-private partnerships where Northrop Grumman performs some of the work for the Air Force, and the other way around, where Northrop Grumman has a workload and the Air Force performs work for us. So partnering together and figuring out where those best capabilities are is something that's really an important area and an area that we can all work on together. Next question here is about technological advances. How does the government find a way to make it affordable and scalable? It's a great question, right? All these new innovations that are coming out, and how do we apply them really broadly? One of the early references I had in my presentation was from Dr. Roper on bending the spoon. And he talks about the tool suite that's being developed for GBSD in partnership with the Air Force and Northrop Grumman. And in there, he shares his excitement that much of that tool suite is going to be made available broadly across anybody in the government here that wants to reuse those tools and make them make them work on your programs going forward. So I think you got to start, and then anywhere we can leverage what another program is already doing and scale from that, it's going to be a lot more affordable. The Air Force has taken on some big rocks for your model-based systems engineering and the tool set that you're going to use there. Having programs aligned with those common tools is going to be really helpful. Also moving to the cloud and focused on the government cloud and having, as Dr. Roper said, owning that tech development stack and sharing that tech development stack is a way to make it affordable and scalable going forward. All right, next question here. Northrop's been a long-time supporter of Log Nation. For transitioning service members, what advice do you have for service members who want to continue to serve in the aerospace and defense market? Great question. We love our veterans. We love our retired service members that are deciding to continue to work in industry and in any company you should continue to work in. I would say one of the things that you need to think about as you transition from a government role to an industry role is, what do you want to do? And there are so many different opportunities out there. As I highlighted on some of the earlier slides of this brief, that you can engage in many, many different areas to help out and make a big difference. As I've seen members that have transitioned to industry, I think it's important that you find a company that aligns closely with your values and what you want to do. I'm usually very honored when I hear people that say, I chose Northrop Grumman because of how ethical the company is, and I know that it's an innovative place where I can work and do well. I would say talk to other people who have retired from military and pick their brain on the best ideas for how to be successful in that. As new veterans join Northrop Grumman, we have programs where we link you up with people have recently retired from military service and help talk through some of the transitions and the differences that come into your new role and how you adapt to a corporate environment, and recognizing that in the military, you may have been in a role where you're able to make a lot more decisions directly on the systems that you're working on. And as a contractor, many times we have to make recommendations back to the government and work together to find solutions there. And if anybody wants to contact me directly to talk in general about ideas there, I'm happy to talk. If you are actually leaving service and you want to join industry, then there's a process we got to go through with the attorneys to make sure that you're not involved with any source selections or anything like that before we could talk about any specific opportunities. And so those are great questions that have come in from everybody here. Thank you for those questions. And Marnie, I see the thank you from you. I appreciate the support from everybody today. It's been great talking with you and being able to share about innovating agile logistics and preparing us for the future fight. So thank you, everyone, and have a wonderful day.